Seismic hazard. Egypt possesses a rich earthquake catalog that goes back to the ancient Egyptian times. Some earthquakes are reported almost 4,000 years ago. Shows the most important historical events affecting al-Sakakini Palace. We can see that the Fayum area as well as the Gulf of Suez is the most important earthquake zones affecting the place. Historical seismicity and maximum reported intensity is a good preliminary index of the expected severity of a damaging earthquake. Available isoseismal maps in the time period 2200 BC to 1995 were digitized and recontoured to determine the maximum intensity affecting the place. This was done using a cell's value of equal area 0.1 lot times 0.1 long. Present the produced IMM intensity showing that a maximum IMM of 7 is good design value. An improved earthquake catalog for Egypt and surrounding areas affecting al-Sakakini Palace has been prepared for the purpose of this study, partially based on recent work of Gamal and Nufel, 2006. The catalog is using the following sources. For the period 2200 BC to 1900, Mamoun, 1979, Mamoun et al., 1984, Bin Minahem 1979 and Woodward Clyde Consultants, 1985. For the period 1900 to 2006, Makropoulos and Burton, 1981, Mamoun et al., 1984, Bin Minahem 1979, Woodward Clyde Consultants, 1985, Riyad and Myers, 1985, Shapira, 1994 and Niak, 2006, Jordan Seismological Observatory 1998 to 2000. Important and historical earthquakes occurred in and around al-Sakakini Palace area in the period 2200 BC to 1995. Maximum intensity zonation map based on the historical seismicity reported in the time period 2200 BC to 1995. The horizontal peak ground acceleration over the bedrock of al-Sakakini area was estimated using McGuire Program 1993. 37 seismic source zones were used to determine the horizontal PGA over the bedrock, while PGA attenuation formula of Joyner and Bohr, 1981 was used because of its good fitting to real earthquake data in Egypt. A complete analysis for the input parameters to estimate the PGA values over the bedrock can be found in Gamal and Nufel, 2006. The probabilistic analysis provided the following results. The peak horizontal acceleration in Gauss with 10% probability of exceedance over 50 years is 144 cm/sec2 or 0.147 grams. For 10% probability in 100 years, the estimated PGA for rock conditions is 186 cm/sec2, or 0.19 grams. Figures 3 and 4. These values are quite high, and considering the local amplification they may affect seriously the seismic design and stability of Sakakini Palace. Seismic source regionalization using 37 seismic source zone, except Greece zones, adopted for Egypt and surrounding areas, Gamal and Nufel, 2006. A. Peak horizontal acceleration in Gauss, cm/sec2, for the seismic bedrock with 10% probability of exceedance in 50 years. B. Peak horizontal acceleration in Gauss, cm/sec2, for the seismic bedrock with 10% probability of exceedance over 100 years.